the coast of Grenada. Based at a tumble-down lime factory, 5 scientists are getting back to basics to solve a series of challenges. This is about science, not survival. Cooperation and ingenuity will be the keys to their success. With nothing more than their wits, some simple tools and the natural resources of the island, our team of scientists will have just 3 days to solve a series of mind-bending challenges. Will our intrepid scientists succeed? Find out next on Rough Science. There's plenty to see on our scientists' new base. But exploring the island involves more than having a good look around. What we'd like is to find out a little bit more about the island. So Cathy and Mike, can you make us a scale map of the northern coastline? And we'd also like an accurate height of our highest point over there.
How many weeks have we got?
Okay. And then Ellen and Mike, if you can help them out, because when they come back with all these reams of information, they're going to need something to put it on. So we need paper, a pen and ink, so we can have a beautiful drawn map.
Oh, no, that'll be fine. We can do
that. Good. And Jonathan, listen to all these birds. Aren't they lovely? Wouldn't it be great to take a sort of recording back of the sounds of the island? A sound recording device, please, Jonathan. As usual, 3 days.
The short straw.
Not even a straw. Disappeared.
You have 3 days to do it, starting now. Let's go. The old lime factory base lies on the coast in the shadow of a high ridge. It's surrounded by miles of inaccessible bays, sandy and rocky beaches. And there's an abundance of wildlife and tropical vegetation, including thick and forbidding mangroves. Mapping the north coast in 3 days would be a challenge for professional surveyors armed with the latest equipment. But our rough scientists only have a kit of basic tools and materials.
It's going to be a nightmare.
Let's do it.
Mike and Cathy haven't even got a ruler, so the first things they need are accurate tools to measure distances.
Cathy, come here. Come and be measured.
What do you want me?
You've got too much hair, you look.
You can go without the hairpiece, love.
Taking an average of our heights should give Cathy and Mike an idea of the length of a metre. And Mike's working on a way to cover a lot of ground quickly, with a bit of help from the kit box.
I found this 10mm spanner. We probably can't use it for large measurements, but this is perfect for taking small, accurate measurements.
Fantastic. Once we've made like a metre out of this, we could check on somebody's height.
If they're right, every turn of this wheel should measure out exactly 98 centimetres. Mike will have to count every single turn as he drags it around the island. Cathy's decided she needs a giant school protractor to measure angles.
And I've started off with a right angle on this thing, and folding it in two gives me 45 degrees. And I can use this to mark off 45 degrees.
Lots of tools taking shape, but to map the north of the island, there's a basic piece of information they'll be lost without. Which way is north?
Using these magnets, just put this needle in there for a few minutes, then it'll become magnetised, and if I float it with cork on water, it should point to magnetic north.
Let's hope so, Mike. If all these fiddly tools do produce the measurements for a map, they'll need strong paper to chart them all on. Ellen's chosen some tough plant fibres which have to be mushed down to a pulp.
This is the milkweed plant, and these are the fibers in it. So I'm pounding it so I can get it all off.
And Mike B's trying to speed things up chemically, using seashells and ashes from the fire to make an alkali solution, basically a sort of drain cleaner that'll break up the plant fibre.
These shells have just come out the oven, and that makes them really easy to break up, and I've got to grind them to a powder. And then when they're powdered, I'll put them back in the kiln, and the calcium carbonate in the shells will form lime. And when I add that lime to this potassium carbonate in here from the wood ashes, it'll form a really strong alkali called potassium hydroxide.
What we want to do is use your, what's it?
Potassium hydroxide.
Potassium hydroxide to break it down enough that the fibers aren't so rigid.
Yes, they interweave.
Exactly.
To make paper.
Yeah.
So there we are. It's a 1-to-1 mixture of a slaked lime and potash. A really concentrated alkali.
Next thing we have to do is add the alkali to it. And begin to break down the cellulose. All right, there we go. Then we just get up, put this on the fire. It'll have to boil for probably 2 or 3 hours. And I'll check it and stir it periodically, and we are set.
Early afternoon, and the mappers are claiming a small degree of success.
Each of these little guys down here is marking out a degree.
How's this going to help you with mapping?
Well, it will help to tell us the height of the mountain, because we'll hold it up like this and hold a plumb line and then angle it and work out the angle of the mountain.
Right.
And from that, we'll also be able to work out the height.
We can also work out how far things weigh by not using it vertically, by using it horizontally. We can use angles to work out from 2 points how far something is away.
Yeah.
That's really clever. So mapping really is all about angles, isn't it?
Not
Angles
all about
and
angles.
distances.
That's where this comes in, you see? It's all very well measuring 2 angles, but you need to know how far apart they are. So, we've got this wheel, and we can measure 100 metres, say, which would be ideal, very, very accurately. 7, 8, 9, 10...
Time for a tryout before the mapping starts in earnest. No paper yet though, so Ellen's found something local to be going on with. Notepads made of leaves from the sea grape tree. Scratching releases sap, which eventually turns white. Unfortunately, that takes about 20 minutes. Kathy's writing blind. But what about our other challenge, to record the sounds of the island?
Hey, I've already recorded something.
What do you mean you've already recorded something?
Yeah, I recorded a donkey.
Absolutely ridiculous and not good enough. So how is this really going to work?
What I've done is I based our recording device on Edison's phonograph, which was made, I don't know, 100 years ago or so. And an Edison's phonograph, which was the first thing used for recording sound, he had a cylinder of wax. If you put your finger just anywhere around there.
About there?
Yeah, and if I turn it, see...
Yeah, ow.
Sorry. So it turns and moves.
So how will that...
Record sound?
Yeah.
I'm going to have like a horn or a cone, which goes to a little pin.
Right.
And then when you shout or talk into the horn, you produce sound pressure waves which go into the can and vibrate the needle, which is sitting on this cylinder of wax.
Yeah.
As you talk, it will wiggle. It will vibrate with the voice.
Wow.
Okay, and so it'll also wiggle the spiral it's cutting in it, and that will record the sound onto the disc.
Okay, so it's exactly like cutting a vinyl record, basically.
Cross fingers.
Late afternoon, the mapping expedition begins in earnest with an assault on the highest peak. Kathy and Mike are desperate to sketch the coastline to size up the problems ahead.
That is one cool view.
A lovely view, but that's the south, and they've got to map the north. And the view north isn't quite as good.
Kathy, I can see another couple of headlands, but I can't very well write.
There's quite a long stretch.
Yeah.
And then it goes out. And then there's quite a big stretch that goes south again.
Right.
So I think the headland looks as though there's kind of 2 little bays, 3 headlands. There may be some small bits off here, but it looked like that was the main
So in our
feature.
sketch map, where's the lime factory?
Around this corner, down there.
Okay, where are we?
The high point kind of around
So the
here.
very, very high points here. So if we mark that and that...
There must be a few more bays around here that we can see, but I think we're going to have to walk there.
I can't quite believe it's ever going to record anything, but it looks nice.
Yeah, it is a bit amazing. Okay, if we start here, can you spoon on a bit of wax, do you think? I think we're going to have to build this up.
Yeah.
I think we're doing just the right thing. We're going quite slowly at the beginning. Making some really wacky shapes at the bottom there. It's brilliant. The cheese phonograph.
The end of day one and the paper people have a problem. The fibres from these tough milkweed stems seem to be just too tough. Plan B. Something altogether fluffier. Time to start plucking.
What a mindless activity. Suits me down to the ground.
This is silk cotton. And apparently I have to get a whole bucket full of this stuff and then go and deliver it to Ellen. And given that I've got half a bucket full in what seems like hours, I think I might be here just for the whole 3 days pulling these things apart. Whether they'll ever become paper or not is a mystery, frankly. Anyway, keep going. Day 2, and my silk cotton is boiling away in alkali to break it down. And Mike's experimenting with squashing flowers to make inks and dyes. But will there ever be a map to draw? How did you get on yesterday?
We went up to the highest point we could reach yesterday, and there's just too much forest there. We can't see the coastline at all, so added to no pen, paper or instruments, we can't actually get an overview of this part of the island at all.
So what are you going to have to do? How are you going to fix it?
I think we've got to rely on Kathy's maths.
I'm afraid so.
Lord!
Well, shall I explain the method?
Yeah, go on.
What we're doing is we're drawing a line along each of the beaches, about 100 metres long.
Okay.
And so if you imagine, here's our line along a beach, like this.
And is that measured with your wheelie thing?
Yeah, we use a superb wheelie device.
And then what we do is find each of the headlands.
Yeah.
And we can see them at each of these points. So imagine that this is a headland over here.
Yeah.
And we want to measure the distance that is away.
From
our beach.
Okay.
So all we have to do, and it's beautiful, I think, really, is if we draw a line over there and draw a line over there, we can just measure this angle using the protractor.
When you say draw a line, is that this is a...
It's just a sight line.
A sight line, okay.
That's about it. 18, Kathy.
So we measure this angle.
Yeah.
We draw a sight line again from this point of reference here.
Yeah.
Like this over here.
Yeah.
And just by knowing these two angles
Yeah.
and this distance here, we can actually work out how far away this point is here. We can compare that with north, because we've got our own compass.
Yes.
And that gives us most of what we need.
So this is basically like, is this trigonometry?
It is trigonometry. It's all that stuff you learned at school.
And I never knew what it was for. Now I know. I think you've got your work cut out.
It's an awful lot of sums.
After a good wash, it's the moment of truth. Can this brown mush turn into paper?
All right, I'm just putting some fiber in. Putting a lid on the jar. Now what I want to happen is the fibers to disperse evenly, let there be no clumps. And see, this is, well, it's not as bad as I thought, but there's still clumps.
There are, aren't there?
But we're looking at, now I'm feeling the time pressure thing.
Yeah, we ought to finish the paper by today.
Yeah.
Look at this.
It's so smooth now,
It's
isn't
perfect. So, is this the big moment?
It is the big moment to try it first time.
Okay.
Okay, so here's our little can.
Yep.
And here's the needle at the end.
Right.
So hopefully when you shout into there, that needle will vibrate a little bit.
Okay.
And encode the voice onto there.
Ready?
Okay.
3, 2, 1, go.
Hello, the next train on platform 3 is the stopping train to Lewis, calling at Brighton, Falmer and Lewis only. That's how they do them. Excellent. Oh dear.
That looks like a right mess.
Let's put it back.
So, what happens now?
We just rewind it.
Yeah.
And then we just play it back. We've got to get it in the same groove.
Through there?
Yeah.
How on earth are we going to get it back in the same groove? How will we know?
I think you can see it. You can see the groove, actually. Don't know where it's going to start. Yeah, I might not start in exactly the right place.
So we might only get the Lewis bit or something.
I don't know. Oh, got to get my spring screwed down.
Sort out your spring, Jonathan.
I didn't get my trains right either. I'll get mugged by some British Royal Guard now on the Lewis line. OK.
Now what happens?
Just turn the handle at the same rate and see if we can hear anything coming out.
Same direction?
Same direction, everything.
OK.
It's about as clear as a British rail announcement.
Halfway through day 2, there have been developments in the mush.
Look what Mike did. You put some of the fibers in a stronger alkali, and look how when you pull it, it's sticking together. This is what paper's all about. So now all I've done is I've just pushed it out. You know, I've pressed it out.
Yeah.
And then I've just been messing with it because I can't help it.
But are you quite confident that this one's going to work?
This is going to be all right. Oh, Mike, this is beautiful! It's beautiful, it's beautiful, it's beautiful. Oh, Mike, oh, Mike, oh, Mike, oh, Mike, oh, Mike. Look at this.
Screaming about?
Look at this, look at this, look at this. Oh, Mike, oh, Mike, oh.
That's fairly good paper.
That was beautiful, that was beautiful, that was beautiful.
That's so fibrous.
You are beautiful.
Jonathan seems to be waiting for inspiration, or possibly a bus home. While somewhere in the north of the island, they're trying to make the map. One step at a time.
We got 155, 160.
Their measurements are covering the coastline with a grid of huge interlocking triangles.
Which headland are we looking at? That one.
Kathy's maths will have to convert these painstaking readings into a 1 to 12,500 scale drawing of the coastline. If they ever get finished, I'm going to check their efforts against a real map of the island.
Only stay in the middle of this little bowl. It looks like we're at the northernmost tip of the island.
So we only have a little bit more to go, I think, Mike.
Yeah, thank goodness.
With day 2 almost over, Jonathan still hasn't produced a sound.
You know, if you sink down in quicksand, don't swim, just lean backwards and put your arms out.
Hey, these are crazy. But Mike, look, there's just no way. I think
I'll try and brave this quicksand too, eh?
Our first 100 metres might have been all right, but the rest is going to be a nightmare.
I wish I had snowshoes or flippers.
Mike, we have to give up.
We're not going to get through here, are we?
It's going to take a long time to go back. I'm tired. We got to go.
Yeah,
come on.
I think so.
One, two, three.
It's the last day and Jonathan's hatched a desperate plan with a tuna can.
So we've got this lovely big cone which picks up the sound and it goes into this little box, which is a bit like a sound box on a guitar. That helps to convert the sound into vibration much more efficiently. So we've got a little nail here, a little pin. And when I talk into here now, you can feel this vibrating really nicely.
Is it going to be a beautiful, dry, white piece of paper?
Not at all. It's going to be damp. It's going to be relatively flat. And we're going to have to dry it and hope the sun comes out.
This works sort of like a flower press, does it?
Yeah.
Is that the idea? It just squeezes all the moisture out.
Look at that.
But actually, it's sort of... Actually, it's pretty smooth, isn't it?
It's really wet.
But it is really wet. So what's the plan? Leave it in front of the fire until the sun comes out?
I reckon so. We've no alternative.
The paper's wet and the physicist is fiddling.
Hello. 1, 2, 3, rough science. Okay, stop.
Kathy's been busy calculating hundreds of angles and distances all morning, still on leaves. No paper or ink yet. But there's still a final measurement missing. With just a couple of hours left, Mike's been left to work out the height of the tallest peak.
100. Right. That's the baseline finished. To work out the highest point, I've got to take 2 horizontal angles and a vertical angle. So first of all, using this plumb line, I'll get the vertical angle. It's a bit fiddly. Might lean it on this for a little bit of support. All right. So, that's the top of the mountain. And that reads 80 degrees, which is an elevation of 10 degrees. Cool.
More last-minute sums for Cathy and her leaves. The paper's finally drying, but now it's a race against time to produce ink.
Sticky cherry. It thickens ink.
Nails, battery acid, makes iron sulfate to make the ink.
This is logwood. It's very hard. And the sinter makes a dye.
You find the water for the ink.
This is the color that's going to be really, really permanent.
What, the logwood?
Yeah.
Right, we'll put some iron sulfate in there. Watch the way it goes dark. Look at that.
Now this is sticky cherry.
Yeah.
Now this will thicken it.
Yeah, don't put too much in. And if we didn't add that, the ink particles would just settle out to the bottom.
Some frantic activity turns plants into dyes and inks.
Hey, all these colours!
Does look cool, doesn't it?
This is the range of inks that we've made for you.
Wow.
This is the range of colours they give when applied to this paper. We've made you 2 brushes. These are your pens.
Have you seen what these brushes are made out of as well? Do you recognise
Colour
that?
looks familiar.
That's Ellen's hair.
This paper looks a bit valuable to mess up, doesn't it?
I'm just going to put holes through each of the key places, through the leaf, right onto the map. I've done that just here. And then that will give me the outline of the most important points that I need to draw. So here goes. Leaf 2.
So needle adjusted? Ready for the second attempt?
Yeah, let's give it another go.
Okay.
1, 2, hey! Whoa! 1, 2, 3. Boom!
Should we try going back?
Yep.
Okay.
That was a bow, wasn't it? That was a bow.
Woo!
Yeah. Hey! Yeah!
I've just about got an outline of the whole thing.
Uh-huh.
I thought what I should do next is mark the position of the highest point on here.
Yeah.
The highest mountain is about 1,640 metres away.
Yeah.
This is my conversion scale here, right? So 400 times 4.
We have a map, but how will it measure up?
Okay. I wonder if it's anything like the real thing.
I better leave you with that or I'm going to pull it in 2. No, I think it's going to be...
But now it's the moment of truth. We have the map. The ink stuck to it.
Yeah.
Yep.
So the paper and the ink, I think we can say was definitely spot on.
This is
But
homemade paper.
This is homemade
It's gorgeous,
paper.
isn't it?
Yeah.
Now this is. I'm afraid we're going to have to take your palm
Okay, the palm
tree
tree
off.
just shows the nicest beach there.
Okay,
And that's the
we'll
chimney.
remember that.
That's the
And
chimney.
that's our
That's
chimney.
where we are.
Okay, well,
Right,
let's
I'll take this
see
conch shell off.
how it matches with this map. We need to do a bit of lining up here. That about there?
Hey.
Not bad. The only thing I would say is our high point is a little skew, guys.
hey, but look at the height.
291, 300 metres.
That's very, very
That
close.
is-
It's very, very good.
So that's
3%
the actual
out,
height and this
that's
is the measured height.
And that is the measured height that Cathy and Mike came up with.
9 metres.
And the mangrove swamps, spot on.
Pretty good.
And
Well,
the point is
guys,
spot on. It's only the sort of boring bits in between that aren't quite...
just where we are
it's
here.
pretty good. Well done.
We were
I
down
think
the south of
big
the
cheer
island,
to
yeah.
you all. Well done.
World Science continues at PBS Online. Point your browser to pbs.org.